Hello and welcome to today's webinar. Our topic is Roadmap 2018 of Flowmon Products. My guest today is Pavel Minarik, who is our CTO. Welcome, Pavel.
Hi, Arthur. Hi, everybody.
I would like to ask you to send us questions that you have on your mind. We will try to answer them throughout the call and also at the end. Maybe before we go into the roadmap, I also want to tell you that the recording of this webinar will be available on YouTube, and we'll send you a link in a couple of days. Pavel, before we jump into the roadmap itself, last webinar was related to our news in the last year or maybe quarter. Could you give me some remarks of what's new in the product before we jump into the future?
Sure. Maybe a couple of highlights that are, I would say, of most interest from the latest news. I will start with anomaly detection system, where we actually introduced, we call it user-defined behavior patterns. And it's a way how actually Flowmon users and partners can extend detection capabilities of anomaly detection system by creating their own detection methods, their own detection patterns, so they can respond to very specific threats in their environment, or they can adjust the detection to cope with their environment. There is also extended visibility into cloud environments. It might look like a small feature that we support VXLAN, but at the end of the day, it's very important, because in VXLAN, you usually transport real network traffic between the hosts that run over virtualization platforms. So with traditional monitoring, you see two IPs talking to each other, and these IPs represent virtualization platforms, and all the network communication is completely hidden. With the ability to understand the VXLAN traffic, we are able to decapsulate this tunneling, and we are actually able to measure real network traffic within the VXLAN. So we can see real hosts talking to each other. We can see all the services, ports, protocols, whatever is provided by Flow Statistics. So this is also from my perspective, very important. We worked on DDoS Defender to improve integration with our technology partners. So at the moment, the integration is very robust to some communication failures with the mitigation appliances. So you can reapply the mitigation policies and all these features to make sure that the mitigation process is continuously running, even when there are some errors in the environment or in the infrastructure. So this would be more or less, I would say the highlights. And of course, we will get to some more in the roadmap presentation, because I also have a summary of latest available versions.
Great, thank you, Pavel. But the main topic of today is the roadmap. So if we can start, and maybe with the main part of Flowmon, or the one that we've actually started with, which is network performance monitoring diagnostics.
Yeah, sure. The roadmap is actually structured in the traditional way. So, you know, Flowmon is a tool or a set of tools for network traffic visibility that helps IT operations as well as security. And we divide our product portfolio into four major segments: network performance monitoring and diagnostics, application performance monitoring, and from the security part is network behavior analysis and DDoS protection. So we definitely start with NPMD, with network performance monitoring and diagnostics. And on this slide, you can see the release schedule. Latest available version is 9.1, where there are some of the features I mentioned to support cloud visibility, so VXLAN or termination of GRE tunnels. We also support Amazon deployment, So basically, we do have a native Amazon AMI image that you can deploy into AVS. This image is now under the certification process, and we expect to have this available soon on the AVS marketplace. So then Flowmon Collector will be available as other products that are actually public available on Amazon AVS. There is also one interesting feature called Flow Proxy, or new flow forwarding engine, that was in detail explained in latest webinar about the news. So just to give you an overview, it's about the capability to capture flows from, let's say, third-party device and forward these flows to multiple different collectors, even in multiple formats at the same time, or even filter the part of the flow data that should be exported to one collector. Another IP range can be exported to another collector. So it's a full flow proxy that can actually collect the flows, that can decapsulate, and that can create new flow exports to different targets. So this was a summary of the latest release available. What is in front of us is 9.2, where we will introduce two major improvements. One is a new application identification engine, so the feature network-based application recognition. We do have updated application patterns, so you can expect improvement and increase of a percentage of flows actually classified on the application level. We will also enable to use PGP for email encryption. So as a user, you can introduce your PGP key, and the report that Flowmon will produce will be sent to your email actually encrypted, so only you can open. For summer, for July, we schedule Flowmon 10 release, so new major version that brings two important features. First one is long-term expected distributed architecture that's scheduled for release in July, as well as we have significantly improved the user interface. So it's a brand new look and feel of how you will experience your work with Flowmon. We also schedule for same date for July new generation of Flowmon traffic recorder. The main features are completely flexible traffic capture criteria, so you can actually combine any filters as you like. I will provide, of course, more details. And we introduce a rolling capture buffer, so an in-memory buffer that will keep raw packets for a certain period of time if they are needed for the capturing process. Later this year, we would like to introduce the native Flowmon collector image for Microsoft Azure.
We have a question, Pavel, for the support of Amazon AWS, whether the collector will receive NetFlow data from external locations, or whether this is visibility into the cloud itself.
Actually, it's not visibility into the cloud itself. It's really a collector that runs as a virtual appliance in Amazon Cloud, and this collector is receiving flow data from probes, routers, whatever reasonable flow sources you have. So it's really a collector operated in the public cloud.
Mm-hmm. And we also have another question, and that is whether we could forward flow data onto an inbuilt collector in the Flowmon probe.
You mean flow data from third-party sources?
From Flowmon sources, but apart from that inbuilt appliance, which means probe with an inbuilt collector will receive NetFlow from other source.
No, that's something we don't plan to do. Probe is really a probe that can collect flows only generated by the probe itself. For capturing flows from any sources, that's the purpose of the collector. So we don't plan to enable that probe will be also able to getting flows from third-party sources, then there is basically no difference between probe and collector.
Thank you.
Okay, so some of these new features probably should go into into more details. So distributed architecture, to give you a feeling how this is going to be deployed. So major purpose is to support large deployments. So Flowmon deployment over multiple locations. Let's say we do have a company headquarters and we have a London location and Berlin location. In each location, we have a local flow sources, so we can have routers, probes, switches, whatever is providing flow data to us. So in each location, we do have a set of appliances. So in London, you can see that we do have two so-called slave units. So two collectors that are processing flow data. And we do have a special device that's called the proxy unit. And the proxy unit is responsible for load balancing the flows over the slave units and controlling the operation of the slave units. For Berlin, we have basically the same situation. And for company headquarters, as this is smaller location, we have just one single slave unit. Therefore, there is no need to have the proxy unit. And the whole system is controlled by a master unit that communicates with proxy units or that communicates with these individual slave units. So this is a brief scheme how you can deploy Flowmon in distributed environment. At the moment, we are also working on more detailed deployment guides, and we are updating our documents and data sheets to include information about these proxy units and about in general all the components of the distributed architecture.
Another question that we have is whether this represents a high availability model.
Actually, this scheme does not represent high availability. For high availability, we plan to do some more development, but the whole architecture was designed with the respect to high availability. So you can have multiple master units, so even not only two, even three if you like. There is always one top priority master who is actually controlling the architecture, but there are like spare units that can jump in when the top priority master is for some reason unavailable. And for the proxy units and for the slave units, actually what you can have this deployment doubled. So for the location London, what we plan to do is to have two same groups of collectors that will process the data in parallel. One is always the active one, and second is not passive, but let's say like a backup. So if the primary one goes down, then you still have everything available on the backup. For this first release, high availability on the slave units, on these flow processing units, will not be supported in Flowmon version 10, but we want to, within the 10 version, add this functionality later on.
Thank you.
You're welcome. Let's move on to some screenshots from the new or updated user interface. So you can see that everything looks a bit more modern, and it's, let's say, more light and more in line with user expectation on how the user interface should look like. So we actually paid attention to feedback that we have received and designed this new look and feel of the Flowmon user interface. So I hope you will appreciate it, and it will look, let's say, more fresh, and it will be also, I hope, more intuitive to use the whole system.
And questions for this? This is a facelift, right? We haven't made any changes in the architecture, or
yes. This is Yeah, we can call it or we can see it as a facelift, like we know from the cars. This is not the new user interface project. That's another activity where we can expect results or some new, let's say, modules or new components of the user interface during next year. Okay, let's move on to Flowmon Traffic Recorder, to the full packet capture module. So basically what we did is fully flexible and general grammar to be able to combine all the filters that are supported in any way with these logical expressions. So basically you can create these complex filters composed of layer 2, layer 3, layer 4 information, as well as selected layer 7 information filters. So this is a way how you can easily focus on what you need and what you want to capture. Second feature is the rolling buffer. So it's basically in-memory storage where you configure the capacity that you allocate to this storage. You configure your history that you want to achieve in terms of minutes, and you also configure how many first packets from each flow you want to keep in the buffer. So this is how you do the initial configuration. You allocate memory for the buffer, and this memory buffer is fully integrated with the probe feature, with the flow cache. So when there is a new record in the flow cache, it will store also first n packets with the flow. So then when you want to trigger the capture, when you want to start the capture, you will also get the data from the buffer. So it has very, I would say, viable impact on the anomaly detection, because you have high chance to catch really the packets that caused the anomaly. Somebody may ask why only first n packets, but it's actually sort of a trade-off between, you know, consumption of a memory and what is the most important. And always the first packets of the connection are the most important. They keep the information, they keep the command, they actually keep most valuable data on what is happening. On this animation, you can actually see how this works. So we do have a records in flow cache, and we store the packets up to the capacity of our memory buffer. And then when there is a request for capture, all the packets that fit the capture criteria will go from the buffer to the capture task. So they will go to a PCAP on the disk.
So the question for the rolling buffer, whether this is a continuous full bucket capture of all communication on the network.
It's not continuous packet capture for all the packets. As I mentioned, there are certain boundaries of the buffer. So basically one limitation is how long you want to keep the data in the buffer, and second limitation is how many first packets from each flow, from each connection, let's say it this way, you will keep in the memory buffer. And then when there is no request for capturing the data, okay, packets will leave the buffer and make space for new packets coming. Mm-hmm. So it's just a memory buffer. It's not stored on the disk, and packets go to disk based on the requests on capturing them and storing them permanently.
Understood. And one question was with regards to the GUI actually. So if we could answer that and then continue to another topic, and that's whether you could change to whether you could decide whether to go for the new look or for the old one, if there is a switch button.
There is not a switch button. It's pretty complicated to actually have both GUIs at the same time. So we have decided not to have a switch button, but we have decided to make this change, and I hope that we will not upset the users. I hope that they will find everything where they expect, because it's really a facelift. It's not moving the features between different modules or moving the features between different screens. So if you are used to find a specific feature on that particular screen, you will find it even after this facelift.
Different colors, same functionalities and same places.
But maybe sometimes the grouping is, let's say, more logical, like in the Flowmon Configuration Center, to group the configuration items in more, I would say, intuitive way.
Yeah, great, thank you.
So we continue with application performance monitoring. Last year, we have introduced the APM transaction generator. So basically a module that is active, that behaves like the user, and that is using a scenarios to actually test web applications, if they are available, how long does it take to respond, if the response is correct. So this was, I would say, most important improvement of the APM offering last year. We have also released APM version 4 that's able to work with the historical data. So if you change the configuration, you can actually recalculate the statistics from the historical data. What we plan to do with APM in future is to integrate it even better with the Flowmon probe. So then the probe is able to parse VXLANs, GRE tunnels, and all this functionality. Then it become automatically available in APM as well, because APM will get the packets directly from the probe software itself. And for the new version of APM, what we plan is a completely new engine. We call it TSA, Time Series Analyzer. And I want to definitely give you more details on that, because it's really, I would say, a revolutionary thing, how we are able to analyze time series and how we are actually do trend analysis or correlation of the time series together. So let's say that we do have an application with the requested SLA on response time 1 second. What we can see that our response time goes up during last 4 weeks. We see an increase around 60%. So this is a sort of a trend that TSA analyzer can provide you as an information. You have this sort of a trend in average response time. Something similar applies to number of concurrent users. So there is an increase about 50% of the number of users. And in fact, these two time series correlate together. So the prediction is, if you don't do something, if you don't improve your resources for that application, you will probably get in 3-4 weeks outside of your requested SLA. So there is a sort of a prediction what is going to get wrong and why, and you will get these automated results and this automated analysis directly from APM. So that's probably all from the application performance monitoring part. And if there are no questions on that, we can move to the network behavior analysis.
We probably need to wait a couple of more seconds for the questions for APM.
Okay.
And I've seen more and more of them. GUI questions are popular, so we'll leave those for the end of the presentation.
Okay.
So we can, yeah.
Okay, so I'll probably jump into the network behavior analysis. This is the release schedule. So what you can see at the moment, the latest version is ADS 9.1, where there is this functionality of user-defined behavior patterns that I mentioned at the beginning. Next release in front of us is 9.2, where we want to do changes in the user interface, in the way how we present events. And we also want to introduce support for intrusion detection system Suricata. That's a sort of extension to the network behavior analysis capabilities. We also plan to extend the scope of reputation databases and the way how we work with them in anomaly detection system. You probably know that there are these open standards, sticks, taxi, to exchange threat information. So we want to work more with these type of sources as well. And next to the original ADS, we also work on completely new generation of the anomaly detection engine that's based on stream processing of the data. I have a dedicated slide to that, so we will get to it. So this is the outline also for 2019.
We have a question for that slide. Will the suricata be included in the ADS installation, or do users need to install it themselves?
It will not be included in the ADS installation itself, but there is actually a suricata installation package provided by us. So actually, normal user does not need to do anything else than to install this package on the probe, to run the suricata on the probe, and that's it. Then it's fully supported in the system, in the user interface, including the open source signatures for suricata. So we want to make this as simple as possible for the users. It's still an option. If you want to use it, you can. If you don't want to use it, you don't have to. And also, if you want to use it, it's free because it's open source. We are not selling open source. So suricata will be provided for free, and you will take advantage of suricata in anomaly detection system. So what we plan to do is actually visualized on this slide. So whenever you have a detected event, detected anomaly, you will actually be able to enrich your context to see also the intrusion detections provided by suricata to get like more understanding and more details on that particular threat or particular attack that we detect and report. So that's the use case for suricata. So I hope I covered the question as well as explained how we are actually planning to use this intrusion detection system.
I believe so. If we haven't, then just leave a further question.
Next topic is a change in the way how we present and how we visualize events on dashboard. Also based on the feedback from users, it's nice to have the traffic colored according to detected incidents, but it actually does not give you any trend or any time series visualization of events, when these events were detected, how many of them. So we want to change from showing the flows. As for showing the flows, we have the monitoring center. So we want to more focus on event visualization and providing insight on what was the time distribution of the detected events. That's basically the idea of a new dashboard in ADS. Last slide that I have related to ADS, I would say the most important one, and it's a shift from this batch processing that we currently use to a new stream processing. What does it mean, batch processing? So flows that are received by the collector are accumulated for 5 minutes, and after 5 minutes, ADS takes these flows and process the events, and process the flows and generates events. So, and this is a process that's happening over and over. Every 5 minutes, you get an update of the detected events. We are changing it completely. We are building new detection engine that's based on stream processing. So actually, flows are being processed continuously as they reach the collector. So the impact is that you can detect attacks and anomalies. You can produce events sooner, actually as soon as you can, as you have all the flows that correspond to event, you can immediately generate the event. And we will also change the concept of the events a bit. The event will start, it will last, and it will end. So we will reduce also the number of events, and we will provide continuous update of these events if the attack is still there, if the threat is still present there. So this is how we are going to change the concept of the event a bit. So that's it.
How much is this going to affect the time necessary for detection? Is the question.
Well, it can actually go from 5 minutes to even 1 second, because it really depends on particular detection method. But if we see, for example, a communication with non-botnet command control center, it will be detected immediately as soon as this flow goes to ADS. So my estimation is that we get from the detection time frame of 5 minutes to seconds.
Mm-hmm. And another question is whether when is this coming, the streaming architecture?
The plan is to release this new generation of ADS is in January 2019. As I said, it's still like an outline because 2019 is pretty far away, but our goal and our plan is to aim to January 2019.
Thank you. And another question to the ADS, whether we are going to allow to collect different log sources, not only Surikata.
We are thinking of it. We are already doing some changes. As you can see, we renamed flow sources in ADS to data feeds. So at the moment, we believe we will have a data feed of flow, of course, and data feed of intrusion detection events. First Surikata, but maybe as the delivery mechanism is syslog, we can actually think of integrating not only intrusion detections from Surikata, but also some other intrusion detection systems. We are having internal discussions how about scanners and this vulnerability management. So there are some ideas, but it's not something decided yet. So I'm not actually able to do any commitments or any claims in this roadmap session.
But we aren't becoming a log manager, right?
No, we don't want to play the role of the log management or even SIEM system. For us, the use case is, okay, we take what we need from those logs and forget about these logs, because we are not there to store all the logs and provide correlation of the logs from different systems. There are products on the market doing this pretty well, and it does not make sense for us to go this direction.
Great. Thank you. Let's maybe continue because of the time, and we'll choose a couple of questions at the end of the presentation.
Okay. Next topic is DDoS protection. So as of now, we do have a latest version, DDoS Defender 4.0. And there are some new releases coming. So in April, we expect to release 4.1, where the major improvement is in the definition of protected segments, also using autonomy system number, which helps to large ISPs and transit providers. And we have also a very unique feature of a continuous update of attack signature. So there is a continuously evolving process of attack assessment and update of the attack signature. In 4.2, you can look forward to have a full REST API covering DDoS Defender, which of course helps not only data acquisition but also provisioning for ISPs or data centers. And we plan to include auto configuration of the protected segments. So basically a special module, special piece of software that will sit on Flowmon and that will actually look for BGP table updates to adjust the configuration of protected segments. There is also a goal to shorten the detection time frame. So we expect to release that October 2018. And for the beginning of 2019, we want to introduce new generation of DDoS Defender that's able actually to handle the mitigation process with more complex rules. So some part of the attack can go to one device, another part to another device, or first we can apply flow spec to get rid of the mess, and then mitigation through, let's say, scrubbing device take place. So more complex mitigation strategies. So if we talk about the features in more detail, this is a screenshot from the user interface showing how you can actually switch between configuring the protected segment by subnets, which is the original option, or using autonomy system number to configure the protected segment. Then we do have a quick animation of how the update of attack signature works. So we do have a service provider backbone. We have Flowmon collector with DDoS Defender. This is the normal traffic flow through the network. We collect flow data. We establish the baselines. We maintain the baselines. In case of attack, we actually detect the anomaly and we start the mitigation process. So we figure out characteristic of that particular attack. So we provide sort of a dynamic signature. In this case, we translate this dynamic signature to flow spec update, and we instruct the routers to drop that particular traffic. But what can happen, and what will most probably happen, is that the attack will evolve, so it can jump to another port, which is a situation that we again see, and we update the BGP flow spec rule to react on evolving attack and change the mitigation strategy.
And so is this a continuous process, or is it based on some regular basis, the checking of changes in the attack characteristics?
That's basically a continuous process. As the flow data are being delivered to collector, we are checking if that attack signature, if that attack pattern is still the same, or if it changed, and then how it changed, and how we should actually adapt the mitigation to it.
Thank you.
I also mentioned shortening the detection time frame from 30 seconds, which is as of now, I mean, plus minus 30 seconds. So it's usually less, it's usually like 15 seconds, but it can go up to 30 seconds. So the goal is to shorten this period to the level of 1 second. So the goal is to be able to respond to attack as soon as we can. That's why we are doing architecture changes to profile the traffic characteristics with the granularity of really 1 second.
And a question to the previous slide, whether we are planning to learn ASIP mapping dynamically from BGP.
Yeah, that's definitely the direction where we want to go. So we want to extract from the BGP updates information that help us to understand what we are actually protecting in DDoS Defender, which IP ranges should be part of which protected segment, and do the changes of the configuration based on these BGP updates. We will start with this. We will see where it takes us, what will be the customer needs, and how we can improve. But what I want to say is that we are not planning to be full BGP analysis tool, like, for example, stability of routing and use cases like that, because again, there are other tools on the market more focused on these type of use cases. So we just want to use BGP for the purpose of DDoS protection. Okay, so that was the traditional roadmap, and next to the traditional roadmap, we do have some development initiatives, some long-term projects. Of course, these projects continuously deliver new features that go to the traditional roadmap, that go to the product. So development initiatives that I want to mention is IT operation analytics, which is a way how we are trying to automate all the data processing or the analysis to find root cause as soon as you can. So basically to get rid of some manual steps and proceed automatically. So one example of an ITOA result is actually the traffic series analyzer that will go to APM, of course. Then we have a very interesting development project that is actually focused on automation of traffic analysis. I mean automation of analysis of full packet traces. So not a Wireshark replacement, but actually a tool that can automatically assess the PCAP and say, okay, so this is probably the issue, this is probably the situation why something is not working. And we also focus on IoT/SCADA, so industrial control systems. What I want to stress is that there are, of course, no limitations in using Flowmon in SCADA environment at the moment, as some of our customers are actually doing, because once you go to IP, once you move to Ethernet, you can easily use Flowmon there. But this development initiative is actually to do layer 7 visibility for specific protocols to get more data and apply anomaly detection principles of this data as well. So what you can expect from IT operation analytics. Let's say that you have a task to be notified when there is, let's say, internet pipe saturation. So you have a location, the internet uplink is saturated, and you want to be notified about that. So you can define an alert if the bandwidth is utilized for more than 80%, more than 8 megabits, for example, you will receive an email notification and you go back to the monitoring center and you see what is actually happening, who is responsible. This manual process can be automated, can be really simplified. So what we want to do is first simplify the alert definition. So simply saying this is my bandwidth, this is my threshold, and then to get not only notification that something happened, but also get full insight what happened, who is responsible, so you can actually see the root cause of the issue and you know how to respond. So what we can do in this case, for example, we can put all the information together. So we can show there is a traffic utilization of, in this case, more than 9 megabits on 10 megabit link. The utilization is there because of a massive download from a website called download.vtransfer.com. And the internal IP responsible for that is this. There's a user that sits behind the IP. The IP sits in a special VLAN, has a MAC address. So you have actually collected all the information about the event and presented this information on a single screen, so you don't need to do manual assessment of the detection. That's the idea of IT operation analytics. Let's move to next topic. So traffic analysis. It's time consuming. You need to work with Wireshark or another tool. You need to know actually what exactly you are doing, what you are looking for. So PCAP analysis is not something easy. And what we are building is a new component, new engine that is able to parse the packets, the individual protocols, and that provides a data to a diagnostics that's built on top of that. Diagnostics can be seen as a sort of a decision tree that goes through the PCAP and points out what is wrong. So let me show you an example. We do have two PCAPs. One PCAP represents a session with mail server from the user where everything worked well. And second PCAP represents a situation when user was not able to authenticate. So we run the automated assessment and we see information that client was connected to a server, that server is ready, there was encryption, no error has been detected, so everything in the PCAP actually worked well. Different PCAP, server is ready, but the user was not able to provide authentication. So the reason why this is not working is actually authentication failed. And this is what you can do with all the protocols like DNS, DHCP, SMTP, even in more complex scenarios. So user tries to connect somewhere, he gets back ICMP message, destination administratively prohibited, for example, and all this assessment can be done automatically and presented to the user as a sort of a result that he can easily understand.
So the question here is whether you need to upload a PCAP into Flowmon that you've captured somewhere else, or whether you could use probes as a source as well.
And the main use case is actually extend the Flowmon traffic recorder. So I have a traffic recorder, I collect my PCAPs on the probes, and then as I have the PCAP in the system, I can run this analysis on top of that PCAP. I assume, or I would expect that we also provide an upload feature for PCAPs coming from third-party systems, because it makes really sense. But the main use case is to apply this on a PCAPs that you get directly from Flowmon.
Thank you.
And last topic I have here is an example from industrial control system. It's an example of IEC 104 protocol, which is mostly used to control energy distribution grids. So what we are already able to do with our probe is actually to monitor these very specific traffic and extend the information on the layer 7 to specific attributes of this IEC 104 protocol, so we know which devices are talking to each other, what is the purpose of the communication, why this message was sent, is it a sort of a periodic reporting of a value, is it a control command. So this is what we know. And then we work with this data in very same way like we work with flows plus layer 7 extensions for DNS and so on. So next step is, of course, integrate this functionality to the product and put it on the market. So during this year, this will be available on probes or on the collector. And for next year, what we plan is to do anomaly detection with this type of data. So you can imagine use cases like why these devices are actually communicating on this command more frequently, why this command changed from frequency once per hour to once per minute, or why we see this command that we have never seen before. So you can find definitely anomalies in this traffic as well. So that's, I think, all from the slide deck. And if we still have some questions that we
have a
didn't
few.
address.
There is not much time, but I would definitely choose one of those related to the GUI, because there are many for that. And that's whether we are going to support HTML5 or whether the GUI will run on HTML5.
Actually, the GUI these days is a couple of years old already. So we are rewriting components, rewriting the JavaScript code. I'm not able to 100% guarantee you that everything will be HTML5 with no exceptions, but it's our goal, and this will definitely happen in the new GUI project. So in the new GUI, we are actually completely changing the concept of how you work with the product. We are completely redesigning the user interface. In this case, it can really be seen as a facelift. So we will rewrite, or we do rewrite most of the components that are needed to be changed after these couple of years.
And one of the last questions that is for ITOA. Do we use also general threshold information as an industry base, comparing the traffic that we can see in the customer's network?
Yeah, you mean something that will work across multiple customers?
This is how I understand the question.
I cannot imagine how this really will work in reality, because it heavily depends on the flow sources, on the quality of the data, and it would be pretty difficult to compare, let's say, a food industry company using as a source of flow data flows from the router, and another food industry company having the probe in the data center. So to answer the question, no, we are not doing this, and I'm not sure how this is actually feasible.
And last question is whether we can integrate third-party threat intelligence into Flowmon.
Yeah, we actually can. In anomaly detection system, you can configure the detection method in a way that it will use your reputation data to detect threats. So you can create custom lists of reputation data or malicious IP addresses that you want to use in the detection. This feature is there already for many years.
And I'm afraid this is the end of the question time, because we don't have much time left. Thank you very much, Pavel, for everything that you've explained today. It was great. We'll have a recording on YouTube soon. Thank you very much for watching. And if you still have some questions, comments, please make sure to send us an email, social media, through whatever channel. Thanks very much again, Pavel.
Thank you. Have a nice day. Goodbye.